Good morning, good afternoon, and good evening to those connecting with me on my YouTube channel. I've made a lot of videos about troubleshooting techniques for detecting problems in cathodic protection systems. And once someone asked me what the minimum equipment needed to carry out these activities was. I find that question interesting and very important. And today I want to make this video for you. What are the minimum necessary equipment? I'm going to talk about the minimum equipment first. And then I'll discuss the additional items we should have available when we're carrying out these types of inspections or evaluations. At this moment I have 4 cars assigned to me, and each car is equipped with the minimum necessary equipment, which I'm going to show you right now. This way, each of the engineers that the client requires to be CP engineers has the minimum necessary equipment. So I'm going to show you at least what I carry in my car, the minimum necessary equipment that I'm talking about. Look, these are the pieces of equipment that I carry in my vehicle, and this is what I consider to be the minimum that an inspector doing troubleshooting should have. I'm going to describe each one of them. This equipment, which is the PCM, is a 150 watt device. This is the power unit, and it supplies up to 3 amperes. We use this equipment to perform current mapping, and we use it almost 80 to 90% of the time. It's very useful for us. In fact, we find and detect the root causes of problems with this type of equipment about 90% of the time, because it shows us the directions of the current and how the currents are distributed in the ground. This is a piece of equipment that needs a power plant. I have a fuel canister and I need a portable power plant. I can also install it in rectifiers, in cathodic protection rectifiers. It can run on 600 volts. Sometimes we are far from the rectifiers as a power source, and I have to carry the portable power plant and extra fuel for reserve. This power plant, when connected, lasts 8 hours continuously without recharge. I can install this equipment in rectifiers using 600 volts. A portable power plant lasts 8 hours. A copper sulfate reference cell is mandatory. This CIA-used measuring rod is for my measurements. A labeled portable current source to avoid confusion. Supplies adjustable voltage and current with cycle interruption. I value this equipment for its. This plant, when I connect this equipment, has approximately 8 hours of continuous work without needing to recharge. The other device we need, which is mandatory, is a reference cell. A half cell made of copper and copper sulfate. I love these gel type cells because they require less maintenance. This is a measuring rod. The same one used for the CIA, but I use it to take my measurements. The other essential piece of equipment is a portable current source. Look, I even have it labeled because I have marked the vehicles. The company I work for identifies them, and each piece of equipment has the identification of the vehicle it belongs to, so there's no confusion among inspectors. This is a portable current source that allows me to supply voltage and current. I can regulate the currents, and I can activate a cycle interruption to make precise current injections. It comes with its connection cables and charger, and I tie them here with a strap so that I don't lose the chargers and connectors. I also love this equipment because it has a way to secure the equipment with safety cables, and I have its padlock. The other essential independent equipment is to have insulation checks using radio frequency. This is the ideal equipment to evaluate insulating joints, insulating packers, and monolithic joints. Since radio frequencies can't travel through the ground, this method is best. Using multimeters for insulation isn't ideal, as AC currents travel through the ground, causing incorrect readings. Always have a clamp meter for measuring rectifier output currents, or where current is injected. Every vehicle should have 2 switches. I love these switches for their practicality and versatility. They can be installed in AC phases. Taps and adjustments include satellite antenna and preset interruption programming. Vehicles should have wrenches, sockets, and screwdrivers. We should cut tape to mark the insulation where we have problems. I used yellow paint, but now use surveyor's tape. Have fuses, replacement fuses, and measurement trims for small currents outside device range, used for current measurements, especially with inverted potentials at crossings. Have replacement diodes, a full rectification block with 4 diodes. Uploaded videos on evaluating diode blocks during inspections. Have cable for temporary electric bridges with alligator clips for bypass tests. I have 2, sometimes needed. Have remotes, 30-meter cable reels for connecting to fences or anodes, or improvising temporary anodes, using number 8 cable for pipes or waterbed. Among the basic tools include wrenches, sockets, screwdrivers, cut tape to mark problem insulation. Now mark it with surveyor tape. Have rectifier fuses, replacement fuses, and measurement trims for small currents beyond device range, used for current measurements, especially with inverted potentials at crossings. Have replacement diodes, a full rectification block with 4 diodes, uploaded videos on evaluating diode blocks during inspections. Have cable for temporary electric bridges with alligator clips for bypass tests. Have 2, needed sometimes. Have remotes, 30-meter cable reels for connecting to fences or anodes, or improvising temporary anodes or waterbeds. Carry 2 reels for connections, and ensure security measures to prevent theft of unattended equipment. We should have replacement diodes. This is a diode block, a full rectification diode block with 4 diodes embedded here. I uploaded some videos on how to evaluate diode blocks during rectifier inspections. I also have this bridge, this cable to make temporary bridges, electric bridges at its ends with alligator clips. So we can also do specific bypass current tests with alligators. In this case, I have 2. We also need them sometimes. Besides this, we should also have some remotes, some reels with cables. These are about 30 meters long because sometimes we need to connect to a fence or to a node and we are far away, or need to improvise a temporary anode. So we use this type of cable, number 8 cable, either to connect to pipes or to improvise a waterbed. At least I carry 2 reels so that I can make those types of connections. And of course we need security measures because sometimes we leave this equipment unattended, and we need to secure both the transmitter and the power plant to prevent theft. So I use this type of wire and secure it in the field. At least I carry 2 remotes so that I can make those types of connections. And of course, security measures, because sometimes we leave this equipment unattended and we need to secure both the transmitter and the power plant to prevent them from being stolen or taken. So I use this type of wire and secure them in the field. Basically, these are the minimum equipment. This is the minimum that should be included. Now I'm going to talk to you about the additional equipment that doesn't have to be in the vehicles. These additional items should be in the office or in the storage where they are kept for additional requirements. I'm talking to you about having a DCBG, having a CIS, and having a portable current rectifier for more powerful current injection tests. The accessories that these devices use, the iframe, to perform CVG. I forgot to show you the receiver. It's the PCM transmitter. I forgot to control the receiver. I'll take a pause. Now, this is the PCM receiver. This equipment, the transmitter and the receiver, is a single unit. In fact, the 5009 case of the receiver is over there. This is the PCM receiver. Remember that this magnetometer, this accessory right here, if this equipment doesn't have the magnetometer installed, it will work like a regular receiver, a detector for inch and wild pipes. But when the magnetometer is installed, then we can do current mapping for this equipment. Right now, I'll show you the additional equipment that we should also have available. Basically, it's to give you an idea that when it's your turn to carry out this type of inspections, or when you're assigned these kinds of activities. First of all, when they ask me, Pedro Morales, what do you need? All of this is what I need to do my job. If we are not doing it, we are doing incomplete work, or it will be much more difficult for us to do it. Sometimes the PCM or current mapping gives me clues that we have underground electrical contacts, and sometimes we will have to resort to using other techniques to help us and be able to give more precise conclusions. Sometimes I am already talking about the additional equipment that must be available in our storage. We need to have an SVG equipment. All this makes up the SVG equipment, the satellite antenna, the cables to measure the remote signals, and the SVG equipment. For my personal opinion, there is nothing better that I am going to do from CBG than from CBG analog. There is nothing that surpasses it. Please note, I do not work for this company. I do not work for this company. I do not work for this company. I do not work for these companies or for these other companies. I am not advertising any of them. As you said, sometimes we need to evaluate the quality of coatings, but this equipment is unbeatable for telling me the direction of the current underground, how the current moves underground. This equipment is the best. These are the mice, which is why I tell you this. Forms the state-of-the-art DCVG with a satellite antenna. It calculates gradients, percentages, and damages. We need a powerful portable rectifier. Unlike the earlier one, which was a voltage and current source, this one also provides voltage and current, but works with alternating current. Hence, we use the generator that fits in the vehicle, similar to field rectifiers. Sometimes we're eventually going to need a powerful portable rectifier, not like the one I showed you earlier, which was a system that is a source of voltage and current. Well, this is also a source of voltage and current, but it works with alternating current. For that, we use the generator, the one I showed you that fits in the vehicle. And it's a rectifier like the ones we find in the field. Sometimes we need this equipment. We need powerful currents that can overcome the resistance of the circuit. At least where I'm working, there are resistors of 200, 300, and 1000 ohms, and sometimes I really need this equipment. Eventually, we're going to need to measure soil resistivity, because sometimes when we're doing troll shielding, we're going to recommend the installation of sacrificial anodes or current and pressure anodes, and we need to measure the soil resistivity to be able to make the necessary calculation. We should also have that available. These accessories are the iframes for the PCM. With this we can do ACVG, voltage gradients through high current. I have two models, two brands, and I have the iframes for each of those pieces of equipment. We should also have them available. We should also have a system available. This one is old, from an older model, but we have the latest generation ones. One is in Houston and another is in Chicago. Here in Atlanta, I have this one in case I need to do something. Especially when we have short casing or pipe crossings on the road, we have this equipment. A short circuit detector in case, or the famous panhandle. Later I'm going to make a video on how to use this equipment. I love it because it has everything integrated, and I don't have to make so many adjustments when I'm using a car battery, multimeter, perimeter piece. This is a really versatile tool. I think not many people know about it. I believe few know about it, but this is the sector equipment. I'm going to make a video about this, but in the field. You know my style, to teach you in the field how to do it and how to evaluate and interpret the results. We will also eventually encounter a lot of interference from dynamic or telluric currents, and we will have to use data loggers. I have these types of data loggers for devices that measure AC voltage and 600 frequency and temperature, and eventually we're also going to have to use these coupons. These are coupons for measuring currents and current densities when we suspect interference or current leaks or discharges. With this coupon, along with these data loggers, we complement the records when we're doing CBG and CIs. For CBG, we need someone to keep wetting the ground, and we use this device to moisten the rods. We should always have this kit available. So, I repeat, this is the additional equipment equipment we should also have on hand in our storage, not like the ones I showed you in the vehicle. That should be in the vehicle. These are the ones that should be in our office, but we need to have them available because sometimes we make decisions like, look, I need to do SVG, I need to do a CEAS. Hey, I have 1 kilo. I need to do a more powerful pre-injection of current. I need to take measurements of receptivities. I need to measure gradients, voltage by alternating current. I have interference, dynamic currents, telluric currents. I need to know what the current density is coming out of the equipment. So I would need all this equipment for that. Once again, I hope you have a great day, a good afternoon, and a good night. It's a pleasure to share this with you, and I apologize for saying goodbye without making this clarification. So I repeat, this is the additional equipment we should also have available in our storage. Not like the ones I showed you in the vehicle that should be in the vehicle. These are the ones that should be in our office. But we need to have them on hand, because sometimes we make decisions like, look, I need to do SVG. I need to do a CEAS. Hey, I have 1 kilo. I need to do a more powerful pre-injection of current. I need to take measurements of receptivities. I need to measure gradients, voltage by alternating current. I have interference, dynamic currents, telluric currents. I need to know what the current density is coming out of the equipment. So I would need all this equipment for that again. And once again, I hope you have a great day, a good afternoon, and a good night. It's a pleasure to share this with you, and I apologize for saying goodbye without making this clarification. I love using this equipment. I repeat, I don't work for them because they have an option that I can activate them via Bluetooth. So I would need all this equipment for that. Again, and once again, I hope you have a great day, a good afternoon, and a good night. It's a pleasure to share this with you, and I apologize for saying goodbye without making this clarification. I love using these devices. I come back and repeat, I don't work for them because they have an option that I can activate them via Bluetooth. Sometimes I'm far from a measurement point as I measure at a rectifier drainage point. I love putting it in this mode. I'll turn on the light. It's measuring AC voltage. This isn't an ad. It's about sharing knowledge. This is the software for this brand. It detects this device. When connected, it shows the equipment reading. I love this function. Though I can't modify readings, I can see the waveform stability and disturbances. I like it with dynamic current. Even with AC voltage, I see abnormal fluctuations. I see line fluctuations. Very useful. Not as detailed as a CIS or oscilloscope, but super useful in the field. I can detect out of sync switches. This app shows it easily. I'll create a disturbance to show its reaction. Creating a disturbance, the reading drops. This is the software for this brand. Notice that it's detecting a device, which is this one here. When I tell it to connect, it gives me the reading that the equipment is taking. I can take my tablet, step back, and go to the rectifier while it's measuring, and I can see it remotely. I love this function, even though I don't have the option to make modifications to the readings. But I can see the waveform, whether it stays stable, if there are disturbances. I really like using it when I have dynamic current present. Notice that even though it's an AC voltage, I'm seeing fluctuations that are not normal in an electrical voltage network. That should be constant. But I can see the fluctuations and disturbances in the line, so it's very useful. It's not as detailed as a waveform from a CIS or an oscilloscope, but in the field, it's super useful for me. I can detect if I have switches installed and if they're out of sync. With this application, I can see it easily. I'm going to create a disturbance myself so you can see how it reacts. There, I'm creating a disturbance. I interrupted, the reading fell through. So we also see that in the field. I want you to notice that I'm the one causing the disturbance. It drops to 0. Notice that it drops to 0. I reconnect it, and well, it's giving me the reading again. Another tool that inspectors should have, and I insist on this a lot, is that when you detect a problem or the root cause of a problem, document the locations for me. So, this is an application called GPS Solver. And think about it. When I take a photo, it records who did it, what you were doing, the date, the satellite coordinates, and the address. If you bring me a photo and you don't bring me this information, the first thing I'm going to ask you is, where is the rectifier from? From Saudi Arabia, Latin America, Mexico, the United States, Canada. Where is it from? No, but I swear I did it in such a place. Yes, but for me, if it doesn't have this description, no, you're not giving me reliable information. I could even question you. So avoid being questioned. Use these types of tools. They're really good and serve as a backup for your professional work in writing. This is what I wanted to add for you. I'm really sorry for saying goodbye, but I consider this one of the most important things that happens. Good afternoon.